And the next speaker is Widad Machmouchi. Machmouchi, sorry. And staying more or less within the same corporate entity, but rather than finding data in the user feedback, we're here doing in some sense, the opposite. Thank you, Widad.
Hello, everyone. My name is Widad, and I'm here to talk to you about a measurement problem we face at Bing, which is how to measure success when the user is not interacting with the page. And I'm here presenting the Bing Online Metrics team. This work is really a compilation of like a couple years of work, multiple years of work, and multiple former and current teammates have actually contributed to this. So at Bing, we really try to address a user intent directly. So in this case, the user is searching for a factorization for 678. And Bing here shows this beautiful answer, right? Like we showed what the divisors are. We give more information about the number, and the user does not interact with the page. They read what they want, and they just leave or go on to another search. In this next example, the user is searching for cafe tutorial. And of course, Bing interprets this as a local intent, and instead of showing the deep learning framework that the user is looking for, so Cafe is actually a deep learning tool that allows you to train your models, we interpret this as a local intent. And we show this relevant answer that covers most of the page. And when the user sees this, they think that Bing is not getting what they want at all. They move on. They never interact with the page. So now we have two examples where the user is not interacting with the page at all. However, in one of them, the user is very satisfied, and in the other, the user is not satisfied at all. So how are we able to tell the difference between those two, given that there are no interactions, or particularly there are no clicks on the page at all? So this is what I'm going to be talking about today. How do we determine user satisfaction in the absence of interaction? So in this talk, I'm going to kind of walk through kind of a timeline of how our solution progressed over time. I'm going to be talking a little bit about the abandonment simulation that kind of tries to quantify the effect of abandonment on a user, on metrics particularly. Then talk about some of the approaches we tried from hybrid measurement that combines both online logs and offline signals, and then ending with our current solution, which is a fully online metric that takes good abandonment into account. And this is by no means like solves all our problems, just that's where we are currently. So before I do that, I want to talk a little bit about A/B testing, just to make sure everyone is on the same page. So at Bing, pretty much every single change is not shipped unless it's tested, particularly in an A/B experiment. So quickly, we take our users, divide them into two sets, control and treatment. Control sees the existing system. Treatment sees the same system with one change only. And then we track our users over a period of time, collecting the logs. And then at the end of the experiment, we collect these logs and we analyze the experiment. And the purpose is to make a ship decision. Should we actually ship this change that we tested or not? So some of the signals that we collect are clicks, queries, how much time the user spent, any kind of client-side interaction that we can get. And then we try to produce online metrics from these. So our online metrics are really simply numerical values that take all of these signals into account and try to produce metrics that measure multiple aspects of the search engine. So we can do like performance. So this tests the health of the system, so page load time, error rates, and stuff like that. We can measure interaction, engagement from the user. So this is like page click rates, click-through rates, and so on. And also we measure user satisfaction. And at the end of the experiment, we produce these. So we produce these scorecards. So you'll have a metric. It has a value on treatment, a value on control, and then we do a statistical test to verify whether the delta that we see is actually statistically significant or not. And all of these values are obfuscated for confidentiality reasons. So I'll be just showing percentage deltas and p-values for reference. In particular, what we really want to measure is really online success. So what we're trying to measure here is a user satisfaction measure that relies purely on the online logs. There's no feedback from the user. The user is just interacting with the search engine. We collect the signals, and we want to quantify the user satisfaction with the system. So how do we do that? So in web search, we kind of divide user interaction into user looking for information or users consuming information. So when the user is looking for information, he's putting some effort into it. So they will be submitting queries, reformulating those queries, examining the search result page, trying to find what they want. But then once they find the URL and click on it, they will be spending the time consuming information. So this is the gain that the user is getting. It's an information gain overall. They might actually get that information from the URLs. They might get that information from the page itself, from the Bing page itself. And our objective is to maximize user utility, so the utility in getting the information that they need. And our access metrics try to capture that user utility. So we look at all the gain, we look at all the effort, and the utility is really kind of a subtraction between those two measures. So what's the success metrics that we use? This is what we call user utility. This work is published, so I'm not going to spend a lot of time on it, just to illustrate really how we measure user satisfaction on Bing. So what we do is we lay down all the user actions on a timeline, ordered by time. So the user issues a query, they click somewhere, spend a long time, go back and search, and do some more clicks before they end their session. So what we do is for every action, we either assign a positive effect on the user utility or a negative effect. So we think of the time spent after the user issues a query as looking for information. So this is a negative time. The user is inspecting the page, the search result page, and they're looking for the information. They have not started consuming that information. However, once they click on a URL and spend a long time there, they're consuming that information. So it overall has a positive effect on the user utility. We go on and do like similar analysis for other interactions that we have. And really, the user utility is going to be just like an accumulation of the utility that you're seeing from each individual event. So the way this happens is for every event, this arrow that you see is what we call the weight. It's a value between -1 and 1, and it correlates with whether that action has a positive effect or a negative effect on the user. However, the utility is also a function of how much time the user spends after they do this action. So this is what we call the payout. This is the amount of time that the user spent either looking for information or consuming information. And then utility will be simply just kind of an integration over all of these areas of the square that you see. So in the beginning, the user is struggling, so it's a negative utility. Next, they go somewhere they like, they struggle a little bit more, and then end their session on a high note. So this is really the measure that we'll be using to measure user satisfaction. The main thing, though, is like how do we account for this concept of good abandonment in this framework? So as you can notice here, there's this query. There's no interaction on it. The user just queried after that. So we're looking at this here as always being negative because the user is searching for information. However, as we saw before, sometimes the user will get the information they need without clicking anywhere. So accounting for good abandonment in utility is really taking that event and making it positive and saying that actually the user consumed information, so it's not really a negative event. And all of our solutions that I'm going to talk about today is actually how to determine when to flip that from negative to positive. Cool. So let's get started with the first solution we had, which is what we call the abandonment simulation. What this tries to measure is how much good abandonment do you need to add in your A/B experiment for your success metrics to make a difference. So if we assume that the treatment introduced some good abandonment, would that make the utility metric positive or not? Note that this is a simulation, so it doesn't tell you whether you have good abandonment or not. It just makes assumption on how much good abandonment you have. So this really requires that your treatment has added abandonment on the experiment. So you can see here that when you measure abandonment rate, we're looking at something where there is added abandonment. So here the p-value is quite small. So there is actually, we're very confident that there is more abandonment that's happening on the flight. So the first step is to measure how much excess abandonment you added. So here, sorry. Wow, okay. Okay. So here, for example, just as a mock example, let's say we have 100 queries on treatment and control, and on treatment we have 50 more abandoned. You have 50 abandoned queries and only 20 on control. So our excess abandonment is really 30 queries overall. That's the abandonment that the treatment added. So next we compute the probability kind of an abandoned query being an excess abandonment, and this is really just kind of a fraction of the excess abandonment out of all the abandoned queries that we have. Note that this quantity is only available on treatment, right? Because only treatment has more excess abandonment. Control does not have any. And the simulation is going to be, we're going to assume that X% of that excess abandonment is good. And this X is going to vary from, the excess is going to vary between 0 and 100%. So at 0%, this is the current version that we have, all abandonment is bad. However, as we go through X being from 0 to 100%, we assume that more and more of these abandoned queries are actually good abandonment. And then the next stage is for each value of X that we determine, we're going to modify this query event in utility and make it positive with some probability. So we're going to make it positive with probability of excess abandonment times this X that we have. So what this does is kind of creates the simulation of the metric. So for each value of X now, we can recompute our utility metric, taking into account that X% of good abandonment added overall. So as you can see here, our original metric was negative. The user was not really satisfied. But then when we start accounting for more and more good abandonment, the metric turns green, and it shows that there's actually some positive effect. So once we have the simulation, how do we actually determine whether there is good abandonment or not? Because all of this at this point is still just a simulation. So in this case, we see that 50% good abandonment of excess abandonment tells you that the metric turns flat, and you need at least 100%. So now we need to verify whether we actually added that much abandonment or not on the flight. So this leads us to what we call the hybrid measurement, which is the next step in our solution timeline. So with hybrid abandonment, now that I know that abandonment can make a difference on my experiment, I need to actually properly measure how much good abandonment I have. So for that, we kind of leverage the kind of more of offline labels aspect of this. So our online metrics are great because they're the user logs. It really captures the user intent because the user interacted with the search engine. However, we don't have ground truth data from online metrics. Offline labels give us that. We can actually collect labels for different scenarios that we have. So that's what the hybrid measurement does. It kind of combines both of these approaches to get a more holistic view of the session overall. So how are we going to leverage offline labels in our metrics? We need a metric that can be easily augmented with new information, and the utility rate metric does that. We need offline labels that are specific to the experiment. So that's what we're going to do. We're going to label actual queries from our experiments, and then we need to properly account for all the variances that are coming from our measurement, because we now have two measurements, offline and online. So this is the task that we collect labels for. So we show the judge the query that the user issued. We give them some session context about it so they understand it better. We also show what the SERP actually looked like, what the search result page actually looked like, and we ask the judge to label as, does this page give the user the information they need? Does it cause good abandonment or not? And we do that for around 1,000 abandoned queries from treatment and control that we sample from the AB experiment. And then, so all of this is uniformly sampled so that we don't introduce kind of any bias in our measurement. So the way we do this judgment is with batches. So our 1,000 queries get divided into 10 batches of 100 each. And each query gets 3 judgments at a time so that we can do a majority label. So if at least 2 of the judges agree that the query has good abandonment, we label it as good abandonment. And then with every batch that's being measured, we compute a good abandonment rate for treatment based on the labels and a good abandonment rate for control. And then we test whether the difference between those rates is statistically significant or not. So after the first batch, if it's still not statistically significant, we move on to the next one. And the reason we do that is for budget constraints. We really don't want to measure more than we need. We just need to verify that there's a difference in the good abandonment rate and what that rate is. So we keep going through these judgments until either we reach statistical significance or we exhaust the 1,000 queries that we're measuring. And then at the end, we have these good abandonment rate for both treatment and control. Note that even if there is no statistic difference between the two good abandonment rates, we still need to compute a pooled one because we know there's more treatment there's more abandonment on treatment, and we need to account for that. So now that we have our abandonment rates, So what we're going to do is for every abandonment impression, we were going to add a new utility event that represents whether there's good abandonment or not. So we're going to kind of determine that with a probability, which is the probability of good abandonment given that impression overall. So really what we're taking is we're taking that query again and flipping it to positive with some probability. So how do we determine that probability? So remember that our labels are produced by judges, so they're kind of sampled from a binomial distribution. And we really need to propagate that variance when we're computing our online metrics. Otherwise, we will be missing that error overall. So the way we do that is, for every impression, we're going to sample this probability of good abandonment based on the binomial distribution we get from our judges overall. So this guarantees that we're still doing the proper error accounting in our metrics overall. So next, we can compute the utility metric. So this is what I'm showing here as the hybrid utility rate. So it's just one example where kind of there's this date answer that shows you the actual date for a holiday. And you can see that our classic utility rate was actually not capturing any of that abandonment. But with hybrid utility rate, it's actually showing a positive effect on the user. So while this is actually a very good way of kind of quantifying your good abandonment overall, however, it's expensive because it uses judgments, and also it takes a while to get those judgments. So it's not very agile for feature teams to wait for that, because you need to run your experiment, then wait for judgments, and then make a decision. So we really wanted a fully online good abandonment solution for abandonment that relies purely on user behavior. So we thought about leveraging those hybrid measurement labels that we have. So the hybrid measurement gives us abandonment impression from actual user logs, and we also have a label for them. So can we use those to actually train a classifier for good abandonment based on the logs that we have? So the way we did that, remember, we only have 1,000 queries from our judgments for every experiment, and we needed more data than that. So what we did is we went back into the experiment traffic, the experiment logs, and we matched the queries with the query that was judged. So that actually expanded our data set. And then for each match query, we still use the majority label to determine whether it's good abandonment or bad abandonment. And then from the experiment logs, we also collected features for every query. So we collected some kind of soft interaction signals. So remember, these are abandoned, so there are no clicks. But we can collect things like scrolls, like page dwell times. We also looked at the user's later activity in the session. So how many impressions they made, page dwell times for these queries, and so on. And more importantly, we computed lexical similarities between 3 queries. So if this is the abandoned query, we computed lexical similarity to the successor one, to the previous one, but also to the prior and the successor. Because this really gives a view of what the user was searching for and how did they interact with the search engine as they're doing these searches. So this is really the tree that we ended up with. So the first node is really, we check whether a query is followed by a competitor query. So by that, I mean, for example, the user searches for Seattle weather, and then they search for Yahoo. So it's actually very rare on our logs. It doesn't really happen that often. But when it does happen, it's actually a very strong signal of dissatisfaction, because the user is abandoning you to go to your competitor, and you really don't want that. So if that's the case, we label this as bad abandonment, and we give it a negative weight in utility. The next thing we check is whether the user took a long time to search again. So for example, they search for Seattle weather, and of course it shows snow, and then they exit the session. In this case, based on our kind of analysis, even like from domain knowledge particularly, is that when the user typically tend to not give up easily. They tend to reformulate if they're not satisfied. So when they really leave after a search, it's a strong signal that they're actually satisfied. So that's why we label this as good abandonment and give it a positive weight. Next, we check whether it's followed by a reformulation. So an example is like weather and then Seattle weather. Maybe we didn't detect the location properly. And reformulation also from the literature and from our domain knowledge is a very strong DSAT signal. So we actually label that as bad abandonment, and we give it a negative weight. The last node here is this high similarity between previous query and next query. So in this example, the abandoned query is Madonna Vogue. So what the user was searching for, I think this is a song. Shania Twain, maybe a singer. So they were searching for this query. Then they moved on to Madonna Vogue, but then they went to a previous search. So based on our logs and based on the labels that we collect, actually this is a negative signal. Going back to a previous query, usually they know that the user was not satisfied with the query they ended up on. So we actually label this as bad abandonment, and then otherwise we label this as, at the end, we label as good abandonment. So we apply this tree for every abandoned impression, and depending on where it ends up on the leaf, we kind of assign either a positive weight for it or a negative weight for it. And we recompute our good abandonment metric for that. So this is also one example of, this is an experiment where we improve the Q&A answer we have on the SERP. So classical utility is actually a negative on this one because all abandonment is assumed to be bad. When we do the hybrid measurement, it makes it flat, so the p-value here is quite high. So the hybrid measurement did not have enough power to detect changes in the experiment. For our GA-enhanced utility rate, we actually see that's actually positive. And not only that, we can see that there is a large contribution to our metrics from good abandonment overall. So this is the current solution that we currently have. It still have quite a lot of problems overall, and there are a few issues that we're working on. But I want to wrap up this talk by illustrating how hard measuring abandonment is. So if we cast this talk as a user interaction, I really would like some feedback from you guys. Otherwise, I'm not going to be able to measure your satisfaction. It's just going to be another abandonment problem I have to solve. So any feedback or questions are greatly appreciated. Thank you. Yes. So we actually use this last decision tree I showed. So what we do is we look at any query that was abandoned, and we try to apply that decision tree on it. And the decision tree, because it's actually using our logs, it actually reflects our user behavior. So really, it's not really a decision that we make in the team. It's more like we train our models based on our user logs. So this really reflects kind of how our users interact with the search engine.
So you had some session information in the decision tree, query reformulation, and template information. The user very quickly went back to the first query. Have you looked at other forms of implicit feedback, like attention signals, or?
So we have some of those, and they might work when you're just like working with a specific data set, except these have to work when you're kind of running experiment on millions of users. So these signals are not as reliable when you're generalizing your decision tree to like, millions of users that you're testing on. There will usually be, so these signals kind of like scrolls and stuff like that are considered not high priority. So if there is any like chance of better serving the user or sending back the signal, we don't send back the signal. So we don't necessarily have good coverage of these features. And while they show up in our decision tree, when we use it as a metric, we tend to, if they don't have good coverage, we tend to drop them. Otherwise, they're just not as useful.
So sparsity is the main issue.
Yeah, sparsity can be a problem, and like interpreting them can be hard sometimes too. But we are working on increasing the reliability so that we can leverage them more.
Do you have different models for desktop and mobile?
So I can't share a lot about that, but we know that users behave on mobile is different, even kind of where they look on the page, particularly that they have to scroll more. So one of the things that we know more is that users on mobile scroll a lot more because it's much easier. So it actually affects a little bit the model that we deal with. So that's something that we keep in mind between mobile and desktop. We try to find different user behavior patterns between the two, and that informs the success metrics that we use.
More curiosity question. Do you compare this with your competitors, for example, for the same keyword search? So Seattle weather, the Yahoo, Google, incorporating, for example.
Yeah.
Can that be used for, say, computing some of this, for example? What do others provide? Are they providing more or better or worse?
True. So that's a more of an offline judgment in the sense that this is not an actual user log that we can look at. We only have access to Bing data, so that's what we will look at. But we definitely have other measurement, like offline measurement, that kind of look at possibly kind of look at comparisons and try to see if we actually kind of ask someone to do a certain search. So you can actually kind of do user studies where users are searching for things on both Bing and Google, and you ask them which one they're satisfied with the most.
How did you build the decision tree which decided if Abandonment was good or bad? Like, talk a little bit about the specific example you used, but I imagine you had a few other examples that probably need to be used to classify the good or bad.
So we rely on the labels that the judges themselves have provided us with. So the label actually correlates with like a query in the log. So we're able to get all of those interactions and the label. So that's how we train our decision tree.
Further feedback? No abandonment.
Thank you.